Hello, I am Wellington Rampazo. My research asks one practical question. Can we catch vulnerable open source components before they become a real problem in production software? Let me walk you through what I found. Open source software powers modern development, but it can also introduce serious security risks that teams discover too late after the code is already integrated or released. The problem is clear. Vulnerabilities are found after the fact, leading to emergency patches and costly incidents. My idea was simple. What if we watched earlier? Monitor what developers download, check it against known vulnerability databases, and alert teams before any code depends on a risky component. The result is actionable alerts, clear vulnerability data for developers, automatic visibility for security teams and leadership, and informed decisions from the earliest moment. The scale of this problem is significant. Between 2020 and 2024, published security vulnerabilities grew from about 18,000 to more than 29,000, a 63% increase. At the same time, NPM alone has over 3 million packages with more than 258 billion downloads. At this volume, catching problems late becomes extremely expensive to fix. My research question was, can teams detect vulnerable open source components earlier, before they become deeply embedded in software? The hypothesis was that monitoring network traffic during package downloads and cross-checking against vulnerability databases could provide earlier warnings. To test this, I selected a set of 8 popular NPM packages. 5 had known vulnerabilities with severity levels ranging from critical to high. The remaining 3 had no known issues and served as controls. Notably, some of these vulnerable packages were still being downloaded hundreds of thousands of times per week. The experiment used 3 virtual machines. Bare Proxy ran the monitoring proxy and custom Python code. DevBox 11 was a Windows machine, and Centurion ran Linux, both acting as developer workstations installing NPM packages. 2 groups were emulated, one monitored and one unmonitored. Both installed the same packages with the same commands. The key difference was that the monitored group had its traffic inspected. Custom code captured each package request, extracted the name and version, and queried the GitHub advisory database for known vulnerabilities. As you can see in the 2 terminal windows, the unmonitored group only saw basic NPM output, ending with a suggestion to run NPM audit manually. The monitored group received the same NPM output, but in the background every package was checked automatically, and vulnerabilities were logged with their severity, advisory identifiers, and direct links to the advisory details. The results were clear. The default NPM audit showed 5 vulnerabilities, 2 critical and 3 high. The monitoring approach found 7, the same 5, plus 1 medium and 1 low that would otherwise have been missed. 3 key takeaways here. First, developers experienced no difference between the 2 workflows. Monitoring added 0 friction. Second, monitoring caught 40% more findings automatically, without any extra manual work. And third, the hypothesis was supported. Earlier and richer security awareness is achievable through network monitoring. Here is how this works in practice. At the moment a developer downloads a package, the monitoring system captures the request. Within seconds, the package is checked against vulnerability databases, and advisories are logged. Within minutes, alerts reach developers, security teams, and leadership before any code depends on that package. Before release, teams can make informed decisions, choose a safer version, pick an alternative, or document the accepted risk. Without early detection, organizations face data breaches, system downtime, financial and reputational damage, and compliance violations. With early detection, fixes are cheaper, exposure windows are shorter, defense in depth is stronger, and design decisions are informed from day one. This research proved the concept works. Turning it into an enterprise solution requires growth in 2 areas. On the technical side, checking subdependencies, handling API limits at scale, improving accuracy across cache states, and expanding to ecosystems beyond NPM like NuGet, PyPI, Cargo, Go modules, and Conan. On the organizational side, connecting to SIEM systems for automatic alerting, creating policies to allow or block risky downloads, providing leadership with risk trend dashboards, and using this data to educate developers in real time. The key takeaway here is important. Logging without alerting is ineffective. The solution must evolve to actively notify and empower teams to act before vulnerable code reaches production. This research proved that it is practical to detect vulnerable components at the moment they are downloaded. Monitoring adds richer visibility without changing the developer experience. Early awareness protects against breaches, downtime, financial loss, and compliance failures. And this approach strengthens defense in depth, built entirely with open source tools that are publicly available. Thank you for watching. Fixing code early is cost effective and prevents catastrophic nightmares. Please read the full paper linked in the video description for the complete methodology and detailed findings.